Still on the application of differential calculus. This time around, we are going to talk about equation of tangents and normals. At any point on a curve, the gradient at that point gives the gradient of the tangent at that point. This is what we are saying. I have a curve, okay, and I have a tangent. The tangent and the curve meet at a certain point. The principle is the gradient of this curve at this point is the same or is equal to the gradient of this tangent at the same point. Okay, so this normal is actually perpendicular to this tangent. Yes, the normal to a curve is a line that is perpendicular to the tangent at the point of contact. Let us use this principle now to determine the equation of a tangent and of a normal. The question says, find the equation of the tangent and the normal to the curve y equal to 2x cubed minus x squared plus 3x plus 1 at the point x equal to 1. So, the first thing is to determine the gradient of the curve at x equal to 1. Now, the curve is y equal to 2x cubed minus x squared plus 3x plus 1. As far as we are concerned here, gradient is dy dx. So what is the dy dx function of this curve? It is, let's differentiate. Differentiate 2x cubed to get 6x squared. 3 times 2 is 6. 3 minus 1 is 2. Differentiate minus s squared and we'll get minus 2x. Alright? 2 times minus 1 is minus 2. 2 minus 1 is 1. Differentiate 3x and we'll get 3. Differentiate 1 to get 0. This is the gradient function. So, at x equal to 1, the gradient of the curve, dy dx at x equal to 1, will be equal to this. In place of x here, we'll write 1. That's 6 times 1 squared minus 2 times 1 plus 3. Okay? This is 1. 1 squared is 1. 6 times 1 is 6. 2 times 1 is 2. 6 minus 2 is 4. 4 plus 3 is 7. So the gradient of the curve at x equal to 1 is equal to 7. Automatically, the gradient of the tangent is 7. To determine the equation of the tangent and the normal, we are going to make use of this formula. Y minus y1 equal to m is the gradient, times x minus x1. Okay? x1 is the point that we have, x equal to 1. So we need y1. Okay? M is 7. That is the gradient of the curve. So how do we get y1? To get y1, in place of x here in this equation of the curve, we'll write 1. So in place of x here, we are going to write 1. y1 will now be equal to 2 times 1 cubed minus 1 cubed plus 3 times 1 plus 1. Okay? 1 cube is 1. 2 times 1 is 2. 1 cube is 1. 3 times 1 is 3. Then plus 1. Alright? So y1 will be equal to 2 minus 1 is 1. 1 plus 3 is 4. 4 plus 1 is 5. y1 is equal to 5. So this is the equation of the tangent. Y minus y1, which is 5, is equal to m. M is the gradient, and the gradient is what? 7. 7 bracket x minus x1. x1 is 1. Remember that point, x equal to 1. Okay, so we can just simplify. We have y minus 5 is equal to 7x minus 7. 7 times x, 7x. 7 times minus 1, minus 7. So let's just make y the subject of the formula. Y will be equal to 7x minus 7. Then minus 5 will cross and turn to plus 5. Minus 7 plus 5. So y is equal to 7x. Minus 7 plus 5 is minus 2. This is the equation of the tangent to the curve at x equal to 1. Having gotten the equation of the tangent to the curve at the point x equal to 1, what is the equation of the normal? Okay? Remember I said earlier that the normal is perpendicular to the tangent at the point of contact. Alright? Now, under coordinate geometry, for two lines that are perpendicular, the product of their gradient is equal to minus 1. So let us say that the gradient of the tangent, which we got as 7, is m1. m1 is equal to 7. And let the gradient of the normal be m2. Alright? Since the two lines are perpendicular, m1 times m2 is equal to minus 1. I hope you get this. For two lines that are perpendicular, we also have parallel lines anyway, but here we are talking about perpendicular lines. We are saying that the normal is perpendicular to the tangent. So the principle is, since the two lines are perpendicular, the product of their gradients, m1, m2, like we just said, is equal to minus 1. So the gradient of the normal, which is m2, will now be m2 is equal to minus 1 all over m1. We just made m2 the subject of the formula by dividing both sides by m1. Alright? So since the gradient of the tangent, which is m1, is 7, it means that the gradient of the normal, which is m2, is equal to minus 1 all over 7, since m1 is 7. So the gradient of the tangent is 7. The gradient of the normal is minus 1 over 7. We are still going to make use of this equation of the straight line to determine the equation of the normal. But this time around, the gradient will now change. So we are going to make use of the formula y minus y1 is equal to mx minus x1. Remember that y1 is 5, x1 is 1, and the gradient of the normal, which is what we got as m2. Let's say m2. Let me use m2 here. It doesn't spoil anything. Is equal to minus 1 all over 7. Okay? So this is the equation. Y minus, what's y1? 5 is equal to m, which is minus 1 over 7, minus 1 over 7, times x minus x1. x1 is 1. Let's simplify. So let's just multiply both sides of the equation by 7. Okay? Let's just say times 7 times 7. We are multiplying both sides, so that this 7 can cancel this one here. That's the point. 7 times y is 7y. 7 times minus 5 is minus 35. Minus 1 times x is minus x. Minus 1 times minus 1 is plus 1. So let's rearrange. 7y is equal to minus x plus 1 plus 35. Okay? 7y will now be equal to minus x plus 36. I can leave the equation like this, or I can write it another way. Depends on the way I want to leave it. I can divide all through by 7. If I divide all through by 7, I'll be having y is equal to minus x over 7 plus 36 all over 7. If I leave it this way, I'm still correct. This is still the equation of the normal. Or I can move these two terms to the left and set the right to 0. That is 7y minus s will cross and turn to plus x. 36 will cross and turn to minus 36. Minus 36 is equal to 0. So if I leave it like this, I'm still correct. Whichever one I choose is the equation of the normal. I hope you get it. Alright. This is how we apply differentiation to determine the equation of tangent and normals. I hope you liked the video. Remember to subscribe, like, and share to your friends and to your classmates. I will see you in the next one. Keep watching.